In our today's mathematics class, we are going to look at fractions. And the word fractions comes from Latin word which says in Latin, franga in Latin, and this word means to break into pieces. It means to break into pieces. Now, as we brainstorm, we should try and understand that fractions are used in our daily lives in most situations. While you are cooking, you can have several spoons of sugar, or maybe you can consider using certain liters of liquids, oil. You can use fraction at sporting, building, when you're mixing ratio of cement and sand, and also shopping. So fractions are used in our daily lives. Now, to understand a fraction is made up of two areas. It is made up of a numerator and it's also made up of another one we call a denominator. It's made up of a numerator and a denominator. Now, we find that a good example would be a number like 3/5, where this is the numerator, and this one here is the denominator. So that is a fraction. You notice that we have a horizontal line here. The horizontal line that we have there is called a vingulum. That is the horizontal line which divides or separates the numerator and the denominator. So we call it the vingulum. So let us now look at the two, basically the numerator and the denominator. A denominator tells how many parts. The denominator tells how many parts the whole is divided into. It tells how many parts the whole is divided into, and the numerator tells you how many of the divided parts you have selected. So the numerator tells you how many of the divided parts you have selected. These fractions have got various areas. It has different areas or a mixture. Now we find that various fractions exist, and we shall look at them. We have what we call a proper fraction. And a proper fraction, also it's known as a common fraction. Now, this fraction, we find that when you have a proper fraction, or what we are calling a common fraction, we find that the numerator is less than the denominator. The numerator is less than the denominator. Then we say that that fraction is proper. For example, 2/7 is a proper fraction. We have what we call improper fraction. Have improper fractions, and here the numerator an improper fraction is a fraction whose numerator is greater than the denominator. And this fraction, an example, can be 5/3 or 1/2/3. So this is an improper fraction. When it is written in this manner, we call it mixed fraction. Now, these fractions, as we have seen, can also be represented on a number line, as we are going to see. So we are saying fractions can also be represented on the number lines. You can represent a fraction on a number line. As we saw earlier on, a number line is simply a number which we have a scale extending right from the left to the right. That's what we call a number line. So we are going to illustrate a number line and see this time how can we use a number line to represent a fraction. So what we have here is this is a number line, and I want us to use this number line and be able to represent a few areas. It's ranging from -2 this side all the way to +2. And if we want to represent here a number, we find that it is scaled. Now every scale here, like this is 0, so from here to this part is -1/2. To reach here is -1, which means another half, which gives us 2 halves, which is 2/2. This one gives us -3/2, and this one gives us -4/2. On the other side, this is 0, so this one is 1/2. To reach 1, we have 2 halves, so this one gives us 2/2. This one will give us 3/2, and we have 4/2. So at this point, you notice that we have a whole scale running from -2 to +2, but we have divided the scale into small portions, and each portion carries a half. That is what we have. Each portion is carrying a half. So you notice that this is a number line. It's extending 2 and more, and this side -2 and more. But what I want you to look at, keenly, is that every small portion has a certain value. And in this particular case, we have got 2 small portions making a whole 1, which is the same as 2/2. Then you'll notice that each portion carries a half. So for us to read 1, it is a half plus a half, that gives us 1, plus another half, that is 3/2. So at this point here is 1.5, and at that end point is 4/2, which is equivalent to 2. So we are saying that a fraction can be simply represented on a number line. Now, if we had been asked from this number line that we have, we are asked to represent the following areas. If we want to show this graph, we have to represent 1.5, and we have to show also -4/2. Then you'll notice that what we require in this case, we look for 1.5. This is a half. This is 2/2, which is 1. 3/2, which is the same as 1.5. So this gives us the mark they are looking for of 1 and 1/2. So this one is done. For 4/2, -4/2, from the central point where we have a 0, we move to the left up to 4/2. This is -1/2, -2/2, -3/2, -4/2. So a point which we require is this particular point, which gives us -4/2, and we shall have represented that. So in other words, we are saying fractions can be comfortably represented on a number line. Take note that the small portions between whole numbers forms a total, that the total small portions forms the denominator value. For example, the units between 0 and 1 are 2 units. And our denominator is 2. Therefore, these small units are the one which forms the 2 units. And as we said earlier on about the denominator, we described a denominator that it lets us know how many parts of the whole is divided into. How many parts of the whole, that is the whole is the number 1. How many parts has 1 been divided into? And this particular case, it is 2. And that's why we are able to say now this piece is a half, and then another half, giving us a 1. Fractions can also be written as whole numbers when you simplify them. I want to take, for example, 4/2 and 9/3. These are fractions. You can have even another one, 5/5. These are fractions, but when simplified, then you'll find that what you'll get is a whole number. So let us look from the first one, 4/2. This, when simplified by 2, 1 by 2 is 2. It gives us 2/1, which is the same as 2. So we're saying that 4/2 is the same as 2. So we've been able to represent 4/2 as a whole number, which is 2. For 9/3, when you simplify, it is by 3, 1 by 3, 3. This is the same as 3. And for the last one, 5/5, this is the same as just 1. So we are saying fractions can be represented simply as whole numbers. We can also represent fractions using area. You can represent a fraction using area or using a region. So we can have a region Now, this is a rectangle, and this rectangle has been divided into 4 equal parts. Take note that the parts must be equal. So, having divided this into 4 equal parts, then we have shaded certain parts and left the others. In other words, we have selected some regions. In our selection, we shall ask ourselves first, how many parts were first divided? You'll find that there are 4 parts in total. And then how many parts have been selected or have been shaded? We find that here we have 1, 2, and 3, so there are 3 shaded parts. Then the question comes, what fraction of the region is selected, or what fraction of the region is shaded? So it is very simple. We look at the question, look at the number of parts, total number of parts, and the shaded parts. You realize that the total number of shaded parts is 3, and the total number of parts that were subdivided are 4. For us to form a fraction, we are going to take what we select. Remember, from the initial definition of a numerator, we said it tells you what has been selected from the total subdivision. And the denominator tells us what the whole has been divided into. So the whole of this has been divided into 4 parts. That one will form our denominator. So we have our denominator there. But for the numerator, it is formed by the number of parts that you have selected or you have shaded. So you'll find that the shaded parts here gives us 3. So this region, we have 4 parts, but only 3 have been shaded. And that's why now our fraction formed from this shaded region is the shaded parts over the total portions, which is 3 over 4. Therefore, we can represent fractions using a region or an area. So let us now understand the numerator and the denominator. Now, I want us to understand the numerator and the denominator. In this case, we shall take a pizza. And a pizza, I think, it's in form of a circle. And we are going to subdivide this pizza. And having subdivided the pizza, we have to select some regions. So our question, question 1, into how many pieces? So we shall handle each question at a time. This is the diagram. Then the question is asking us into how many pieces has the whole pizza been divided. For that question, count all the number of pieces that pizza has been divided into. And that one you'll notice, if we start from here, this is 1, 2, 3, 4, 5, 6, 7, 8. So we can conclude and say the total number of pieces of subdivision here is 8. Part 2, how many pieces have been selected? How many pieces have been selected or have been shaded? Now, for the first question, it was asking us the total division. But the second part is asking us how many pieces have been divided or selected. So this particular case, we look at what has been shaded. That is what we've selected. So we find that we have selected 1 here, 2, and 3. So there are 3 pieces. Those are 3 pieces that have been selected. Take note that Total division, that is divided, is 8. Selected is 3. Question C. In simplest form, when representing the shaded region, one, what must be the denominator in this particular case? What is our denominator? Or what should form the denominator from this particular division of pizza? 2, what should form the numerator? And lastly, part 3, write the amount of pizza selected as a fraction. So, from our definition initially, we say that the total division gives us the denominator. So, we are being asked what must be the denominator. From this particular case, the denominator will be formed by the total number of division this pizza has been divided into, and when we count the total, it gives us 8. So this one is 8. And what must form the numerator? Numerator is formed by what has been selected. What has been selected here is 3. So, to write down the amount of pizza selected here as a fraction, we are going to first take the numerator, and the numerator has been arrived at as 3. So as a fraction, the numerator is 3, and the denominator here is 8. So we can say that the fraction of this pizza that has been shaded is equivalent to 3 over 8. 3 over 8, where the total division, which was 8, is our denominator. The shaded part, which was our numerator, forms 3. So this is the fraction we are looking for. So let us look at a question that touches on representing a fraction on the number line. And we should see how this should be shown. So question 2 here, represent (3 over 5) and 9 over 5 on a number line. Represent 3 over 5 and 9 over 5 on a number line. So in our solution here, the first thing we need to have or look at is come up with a number line. And before we come up with a number line, we need to understand from the fraction that we have, how many units are going to form the whole. Because initially we looked at the definition of the numerator and the denominator, and we said a whole simply, when we divide a whole, it forms the denominator, which gives us a number of divisions to form a whole. So in this particular case, we are going to have a number line, but with small portions of 5 units between 1 and the next whole number. So we shall have a number line then from this number line that we have, remember we have to represent 3 over 5 and 9 over 5. Both of them are positive. So if we choose to start from here and say this is where we have our 0, then we should have 5 units before we arrive at another whole number. So that simply means we have 5 equal units. So we have our number line here, and between 0 and 1 we have 1, 2, 3, 4, 5. There are 5 pieces, which implies that every single subdivision or portion here represents a fifth, or 1 over 5. So we have 1 over 5, 2 over 5, 3 over 5, 4 over 5, 5 over 5, which forms 1 here. Then this is 6 over 5, 7 over 5, 8 over 5, 9 over 5, 10 over 5, and so on. So this is what we are getting. So for every fifth put together, we have 5 small pieces giving us a 1. Let us see where we shall locate our part of 3 over 5. So looking at this is 1 over 5, 2 over 5, 3 over 5 is here. So we can simply say this is the part where we have 3 over 5 on the number line. The second part is 9 over 5. Looking at what we have, 9 over 5 is somewhere here. So we have been able to use the number line to represent 3 over 5 and 9 over 5 on the number line. Remember, what guides us is the denominator, and the denominator here was 5, and the same 5 is the one which formed the number of portions between one whole number. Question 3. Represent the fraction (3 over 4) in 3 different ways. In 3 different ways. Using a square diagram. So the question reads, represent the fraction 3 over 4 in 3 different ways using a square diagram. So in our solution, now because in this case we want to use a diagram to illustrate the fractions here. So we strictly need to use a diagram, and we should make sure that our diagram is at least on proportion when we make the divisions. So the first part, we have to draw 3 squares. So we have 3 squares here. We want to represent 3/4 in 3 ways. So each square will have its own way. For the first square, let us divide the square using the diagonals. And then they are asking us 3/4, which implies that we have to select 3 pieces out of 4. You notice that now from the division, we have 4 equal parts, which forms our denominator, but we want the numerator which is selected, and that is 3. So we shall shade what we shall require. So we have shaded 1 here, 2, 3. This remains unshaded. So you'll find that this part here we have 3 shaded out of the 4 pieces in total. The second way, that's the first way done. The second way, we look at this square, and this time we divide it using horizontal and vertical lines at the middle. We have one maybe moving downwards, another one across, so that we have 4 small squares, and the 4 small squares, assuming they are proportional and they are equal. So from this, we are going to select 3 portions, and when you pick the 3 portions, we shall select, this is the one, this is the second one, this one is the third one. What remains is the 4th. We don't need to shade 4. We want to select 3. This is 1, 2, and 3. Having selected that, it means that 3 have been selected and 4 out of the 4 units. So the whole of this shaded part represents 3/4. The 4th method is to divide the square that we have into small equal vertical rectangles. So we have got 4 vertical rectangles, and they are equal in width. Now, these 4 of them, we want to select 3 or shade 3. So we shall pick the first 3 here. So we have shaded 3 out of the total 4. This is the first shading, the second shading, and the third shading. So you realize that the shaded region is 3/4 when we represent it as a fraction. So the question was to represent it in 3 different ways. So the first way, we have used diagonals to divide the square. Second way, we have used horizontal and vertical middle lines to divide that particular square. And the 4th way, we have simply divided the square into 4 equal rectangles, and we have been able to identify the first 3 rectangles as 3/4. So let us look at the following questions first. State the denominator of this proper fraction, 2 over 9. 2. State the numerator of this improper fraction, 7 over 5. And 3, we have group the following list of fractions into proper fractions, improper fractions, and whole numbers. So let us look at the list of fractions that we have. Oh, these are the groups of fractions we are going to group. But let us first start with the first one. We need to identify which one is the denominator of this proper fraction. As we said earlier, that the denominator is what is down on the fraction, which implies that this one here, that is 9, will form our denominator. 9 forms our denominator. The second question, state the numerator of this improper fraction. So it's not always true that the numerator should be the one which is larger than the denominator. For improper fractions, we first said that those are those fractions whose numerators are larger than the denominator. And if the denominator is what is down, so 5 is our denominator, which implies that 7 in this particular case is our numerator, as much as it is larger than the denominator, which is 5. So 7 forms our numerator. So we are done with question 1 and 2. So for question 3, we have been asked to group the following list of fractions into proper fractions, improper fractions, and whole numbers. So for our solution here, we are going to divide, because we are grouping. Let us have proper fractions here. So I've been able to separate, and now we only need to allocate the fraction. We shall look at each. The first one is 7 over 6. 7 is larger than 6. That one gives us an improper fraction. So we shall look at where we have improper fraction and locate there. So we have 7 over 6. B is 2 over 7. 2 is smaller than 7, which means this is a proper fraction. So we have 2 over 7. C is 50 over 7. 50 is larger than 7. And when you simplify, it cannot actually divide 50 evenly. Therefore, 50 over 7 is improper. So we have the second one here, 50 over 7. C, this is 3 over 3. 3 over 3, they are the same. They are equal. When you simplify 3 by 3, you find that it's 1 over 1, which is 1. So we shall say 3 over 3 is a whole number. Next we have 3 over 4. 3 is less than 4, and 3 is numerator, 4 is the denominator. So this is a proper fraction. So we have 3 over 4. 5 over 11. If the numerator is less than the denominator, automatically that one gives us a proper fraction. So 5 over 11 is a proper fraction. 1 over 99. 1 is smaller, 99 is too large, so we have 1 over 99 as a proper fraction. 9 over 4, and we cannot simplify 4 and 9, so this one remains the way it is with a larger numerator which forms improper fraction. So we have 9 over 4. 1 over, this is 11 over 8. 11 is larger than 8 and cannot be simplified, so this one forms also an improper fraction, that is 11 over 8. We have got 10 over 10. It can be simplified further to be 1 over 1, which is just 1, which is a whole number. So 10 over 10 forms a whole number. 5 over 1, it would have been an improper fraction, but 5 divided by 1 is just 5, so this is a whole number. So you have another whole number here as 5 over 1. 121 over 5, it is not divisible by 5. It is larger than 5. 5 is the denominator, therefore this forms an improper fraction. That is 121 over 5. So we've been able to group this group of fractions as either proper fractions, improper fractions, and whole numbers. That is how we handle that particular part. Okay, let's look at another question. Write the next 3 fractions. For each of the following fraction sequence. For each of the following fraction sequence. Those are our questions. We are supposed to complete the sequence given that we have fractions listed and then we have blank spaces. We need to fill the blank spaces by filling in the sequence. In any number where we have sequence, we should be able to study the pattern and see what is causing the other digit or the next digit or the next number to be the way it is. So we have 3 over 5, 4 over 5, 5 over 5, 6 over 5. You realize that here, what's happening is that we are adding the numerator or increasing the numerator by 1. That is 3, 4, 5, 6. But the denominator remains 5, which implies that the next number we shall expect from 6 is 7 over 5, 8 over 5, and 9 over 5. The sequence here was arrived at on looking at what is happening or what is the pattern of the previous numbers. The next one we have 9 over 2, 7 over 2, 5 over 2, and 3 over 2. So what is the relationship between these gaps here? Because already on the denominator we don't have any change. The denominator remains 2. So I'm sure the denominator will remain 2. But for the numerator we need to study the pattern. From 9 to get 7, they subtracted 2. 7 to get 5, they subtracted 2. And 5 to get 3, they subtracted 2. Which implies to get the next digit here, we subtract 2 here. And what we get here is 1. What follows here, we need again to subtract another 2. We did integers and we dealt with negative integers when subtracting negative integers and adding negative integers. So in this particular case, it's 1 plus negative 2, which is the same as 1 minus 2. You realize that you arrive at negative 1 over 2. Then again, we add minus 2. You'll get here minus 3 over 2. You'll notice that at any given point, we have negative 2 here. 1 minus 2 is negative 1. 3 minus 2 is 1, and so on. So the pattern here is the first digit is actually, we are subtracting 2 to get the next. Let us look at the last example. The last example we have 18 over 4, 13 over 4, 8 over 4, and 3 over 4. The denominator has not been tampered with, so we shall maintain a 4 all through. But the pattern between the numbers that we have here is what we need to consider. Now 18 and 13, we have a difference of 5. 13 and 8 is a difference of 5. So we are subtracting 5 at any given point here. So 3 minus 5 gives us minus 2. Then 2 minus 5 gives us negative 7. And this one will give us negative 12. So every pattern or every next digit has been generated by subtracting the numerator, subtracting from the numerator minus 5. That is why we are arriving at these numbers. Now that brings us to the end of the first part of fractions. In our next class, we are going to look at equivalent fractions in simplified forms. Thank you.